This video looks at how we can use subqueries in SQL. They're an important tool for certain types of queries that we might want to carry out. In a previous video, we looked at the notion of an aggregate function, and we saw that if we wanted to get the largest capacity of any room in the CAS building, we could use the query that you see here. The from clause gives us the full room table. We then use a where clause that includes the like operator, and so we do pattern matching to get all rows in which the name of the room begins with the letters CAS. And then finally, the select clause has our aggregate, the max aggregate function, that will take the 5 capacities that were selected by the where clause and extract the largest of them, which is 500 in this case. Now, presumably, if we're doing this query, we actually want to know which room has that capacity. And so if we want the name of that max capacity room, how would we find it? Well, it might seem like we could come up here to our select clause and just put the name in there along with max capacity. But it turns out this does not work in standard SQL. And to see why, if we actually were to execute this, we again would get the same rows as before because the where clause hasn't changed. And then if you think about what each component of this select clause gives us, the name component here, if we just had select name, we would get the entire name column of the portion of the table that satisfied the where clause. So that would give us 5 rows. If we're getting max capacity, however, that's just a single number. And so there's a mismatch here, and we end up with an error. There's no way for SQL to know which of these values from the name column should be paired with this single number. And so we cannot take this approach if we're using standard SQL. In general, a select clause cannot combine an aggregate function with a column name that is on its own outside of any aggregate function. So here we have a column name by itself, here we have an aggregate function. Those two things cannot ordinarily go together, although we will be seeing an important exception to this rule soon. So to solve this problem, we're going to use a subquery in which we nest one query, one select command, in the context of another one. And this is what it looks like. The subquery is highlighted in blue here, and you can see it's the previous query that we looked at that just finds the largest capacity of any room in CAS. And you can think of that as getting done first. So it's part of the where clause of this outer query, but it's essentially going to run first. It's going to give us the 500, and so now we know which capacity we're looking for. And then we have this outer query that selects the name and capacity of rooms whose name matches our earlier pattern, so rooms from CAS that have a capacity that is equal to the result of the subquery. And so we'll end up with CAS rooms that have that largest capacity. And potentially there could be more than one, although in this case there ends up being just one. Now if we look at our query, it's worth noting that we end up repeating the pattern matching condition twice. It appears inside the subquery, and that's necessary because if we didn't have it there, we might not end up with the largest capacity in CAS. We would get the largest capacity in the entire room table, but it might not be in the CAS building. It might be somewhere else. And then it has to also be in this outer part of the query, because otherwise we might get other rooms whose capacity happens to match the result of the subquery. So for example, if the result of the subquery is 500, then we would end up, if we took this condition out, this name like CAS, we could get rooms anywhere on campus, anywhere in that room table that happen to have a capacity of 500. Now when it comes to other uses of subqueries, a really important one is to test for either the presence or absence of set membership. And we do this using two special operators, in and not in. To give you an example of this, let's say we want to find all students who are not enrolled in a given course, like CS 105. This is what the query looks like. And you can see we have a subquery here. It runs first. It takes the enrolled table, and you can see the where clause narrows things down to just the rows in which course name is CS105, and then the select clause of the subquery gets just the student IDs from those rows. And so the subquery is giving us the student IDs of students who are enrolled in CS105. And then the outer query is working with the student table. And you can see what it's doing is going through that student table, looking for students whose ID is not in the result of the subquery. So we start with Jill Jones. Her ID is in the result of the subquery, and so she's not going to be selected by the outer query. Then we move on to Alan Turing. His ID is not in the result of the subquery, and therefore not in gives us true for his ID, because 25252525 is not in this set of IDs produced by the subquery. And therefore, the name of Alan Turing will be part of the final result. Then we go to the next row in student, and we see that Audrey Chu's ID is in the result of the subquery, so she's not going to be selected by the outer query. But Jose Delgado, his ID is not in the set given by the subquery, so he's included in the result, and so is Count Dracula, because his ID is not in the result of the subquery. And so our final result is these three names. They are the students who are not enrolled in CS105.